So now we're going to be doing some examples related to bearings. Example number 1. Chris walks 5 kilometers south, then walks on a bearing of 36 degrees true. So now we're dealing with true bearings. Until he is due east of his starting point. How far is he from his starting point? Now, there's a lot of information just to do in one reading. So the way I like to do it and the way I want to advocate for you to do it is break up the question and write down the information as you go along. So Chris walks 5 kilometers south. So in other words, wherever he starts off from, he's going to be walking 5 kilometers south. And we know south would be in that direction right there. So if you want to call that as O for his origin, for his starting point, and now we know that he's traveling all the way down to this point right here. So we know Chris walks 5 kilometers south. So wherever he started from, so let's say he just starts at this point right there. And we're just going to call that O for origin. You can even call it point A. That's up to you. And we know that he's going directly south up until he gets to 5 kilometers. Then he walks on a bearing of 36 degrees. So now he's walked 5 kilometers. He's ended up over here. Let's just call that point A. And from there, he's now walking on a bearing of 36 degrees. Now, 36 degrees would be somewhere right there. So that angle there would make up 36 degrees. Now he keeps walking until he's due east of his starting point. Well, let's go back to the starting point O, and he's going to keep walking on this line all the way up until he's due east of his starting point. So what that means is if we go back to his starting point, let's go all the way due east. If you notice, that's the point that we hit right there. So now, is he going to go all these extra kilometers or extra meters? No, he's not. So that's why we also need to stop our line there as well. And at that end point, I'm also going to be drawing up a compass. And let's just call that point B. So now let's just do a quick revision of, or let's revise over what the question has stated. Chris walks 5 kilometers south. So all the way south until he goes to point A. Now from point A, he goes on a bearing of 36 degrees until he is due east of his starting point. And how do we know that he's due east? Well, let's go have a look. From O, we're traveling directly east up until we hit the point B. Now, if you notice, what do you see over here now? What have we just created? We've created a triangle, but in specific, we've created a right angle triangle. So it's very important to analyze from here on out. So now the question is, how far is he from his starting point? Well, this is where he ended up at point B, and he started off at point O. So now the question wants us to find all of this right there. So let's just call that X. Now, if your diagram's a little bit messy or you feel like, it's just better to write it out again, go ahead and do so. And that's what we have left. So now, because this is a right angle triangle, can I find the other side using Pythagoras? No, I can't, because I don't have another side. So what's the other option that I'm left with? SOHCAHTOA. So remember the trig ratios, sine theta, cos theta, tan theta? That's what we're going to be looking at. So if we have a look at the angle, we have the opposite side, and we also have what we call the adjacent side. So now, opposite and adjacent, the trig ratio is going to be tan of 36 is equal to x, which is opposite, and 5, which is the adjacent. And then just simply multiply the 5 over to solve for x, and we're going to get x is equal to 5 times tan of 36. Now just put it in your calculator, and that's going to be your answer. Now, if I was just to round this off to one decimal place, this is going to become 3.6 kilometers. So in other words, he is 3.6 kilometers away from where he started off from. Okay, let's have a look at example 2. Now, the way I'm going to do this question is, see, normally I would read the whole thing and then I would go back and I'll analyze it, but I'm going to cut out that first step. I'm going to cut out the fact that I'd read the whole thing. So what I'm going to do is as I'm going along, I'm going to show you my thought process, and I'm going to show you the way you guys should actually start doing these worded problems. So let's start. Two cyclists leave from the same point. Okay, so far I know if I had a point right there, right? Two cyclists, they're leaving from the same point. So in other words, one of them can go in that direction, one of them can go there, or they could go there. They could even both be going to the same direction. The point is that they're leaving from the same point. Okay, so it says one cyclist travels due west. They start off at the same point. One of them is going this way, due west. And let's say he just stops right up until there. So let's call this guy, the first cyclist, A, while the other travels on a bearing of 202 degrees. Now, where is that 202 degrees from? That's from the starting point. So if I say whereabouts is 202 degrees, well, that lies in this quadrant right here. 202 degrees will be right there. Now, hold on. Remember, 202 degrees will be from north all the way up until that point right there. Now, let's analyze that part a little bit further. If the whole thing was 202 degrees, that means from here to here would be 180 degrees, right? So then they're traveling this extra piece of angle right there. I'm just curious, what would that angle there be? The way I would do it is I'd go, well, the whole thing, 202, and I'd get rid of the 180 part because that's the part I don't want. So that would equal to 22 degrees. So what I'm getting at is this angle over here would be 22 degrees. And again, I am just analyzing and I'm doing this question as if I am actually doing it as if I'm a student. So let's keep reading. After 18 kilometers, so now the second cyclist has been traveling for 18 kilometers. The second cyclist is due south of the first one. Okay, so now we've got something to play around with. It says after the 18 kilometers, the second cyclist is due south of the first one. So if I go back to the first one, what the question is saying is that the second cyclist, if he was to keep continuing for exactly 18 kilometers, he is going to be due south of A. So now that's the part where the second cyclist would have ended up. And as you can see, the second cyclist, B, is directly south of point A, the first cyclist. Okay, so now let's just keep analyzing, right? Let's go back to this 22 degrees here. Remember one of the points that I mentioned to you guys, so one of them to look out for, and that was the alternate angles. So with that angle right there, let's see if there's any angle, or let's see if we can find some. If that's 22 there, guess what? This angle right there, that would also be 20 degrees, 22 degrees. Now look at this. We've created the triangle, or that's what we have ended up with. We know that that's 90 degrees. So now we're dealing with a right angle triangle. We have a side, which is 18 degrees, and we also have the angle inside, which is 22. Now let's see what the question wants. How far has the first cyclist traveled? Now remember the first cyclist, he started from O and he went all the way due west to point A. So in other words, the question is saying, what's that distance right there? And as you can see, it's very similar to the previous question that we did. Now, if you can't work with this diagram that we had, that's fine. Draw it up again just for your own sake. Okay, so now how are we going to find x? Well, since it's a right angle triangle, the only option that we can do is to use SOHCAHTOA. Now, according to the angle, what do I have? Well, I need to find the opposite side, and they've also given me the hypotenuse. So ask yourself, what's opposite and hypotenuse? That has to be sine. So sine of 22 would equal to x over 18. Now solve for x, multiply the 18 to the other side. We're going to get 18 multiplied by sine 22, and that's going to give us our value. x is going to equal to 6.742918, so on and so on. Now, if the question said, give your answer to the nearest kilometer, this would end up becoming 7 kilometers. Example number 3. So I'm going to do this one as if I were in a test and I am doing it myself. A boat travels 90 kilometers from point X to point Y. Okay, so given that information, let's write that down. Travels 90 kilometers from point X. So if point X was right over there, it's traveling 90 kilometers to point Y. So point Y would be my endpoint on a bearing of 65 degrees. So I know 65 degrees would be around somewhere there. And it did this for 90 kilometers. So that point right there will become point Y. Now remember, at every single point, we're going to be drawing up a compass, and that's point Y right there. So now that it's at point Y, it then turns and travels on a bearing of 140 degrees from point Y to point Z. So what that means is, it's now that it's at point Y, it's traveling to point Z on a bearing of 140 degrees. And we know that 140 degrees would be somewhere right there. Now, just to analyze, right? That's 90 degrees, and the whole thing has to be 140 degrees. So what would this angle right over there be? Well, it'll just be 140 minus 90, which would give us 50 degrees. So now if that's 50 degrees, what would this angle over here be? Well, that'll just be 90 minus 50, which would give us 40. So that there is going to be 40 degrees. Now, is there anything else that I can analyze? Yeah, remember the alternate angles? Let's go ahead and find one. Now, let's go back to this 65 degrees over here. If that was 65, that means this angle over here, guess what? Would also be 65 degrees. So now I'm getting somewhere. Now I'm actually putting information into the question, and I know this is going to help me. Let's keep reading. Point Z is on a horizontal line from its starting point. Now, remember how we started off at point X? It's saying that point Z is on a horizontal line from its starting point. So guess what? Right at that point of intersection right there, that's going to be point Z. Okay, so let's keep analyzing. If this over here was 50 degrees, so this is the one that I'm looking at, remember, let's see if we can find some alternate angles that link to that. So if that was 50 degrees, guess what? This over here would also be 50 degrees, right? What about this angle over here, the one towards the left? Well, if that green angle over there was 65, then that would just be 90 minus 65, which would give us 25. So that angle right there would be 25 degrees. Now, is there anything else that I can analyze? That's pretty much it. Just for fun, I could say, you know what? That's also 40 degrees. This would also be 25 degrees. And I think I've analyzed every single bit of the question. There is nothing more for me to do. So now let's see what the question actually wants. How far is the boat from its starting point? So now we know this. This is where the boat ended up. This is where the boat had started. So the question says, how far is that? So I'm just going to label all of this, which is what we're trying to find, as A. So now we're trying to work out a way to find A. All right, so as you can see, this whole triangle business, it is a bit messy. So what I'm going to do is I'm going to redraw it, but only drawing the important information that I need. So, okay, and there you have it. That's all the information that I need. So the question is saying now we've got to find point A. Now look at this. All the previous problems that we've done, we've been dealing with right angle triangles, but this one over here, look at this. This angle here is 25, that's 50, and that's 105. So if you notice, there is no right angle triangle. So I can't just simply do SOHCAHTOA, sine theta, cos theta. I can't do that. So now I need to work out another way to find that side over there. So now how do we go about doing this question? Well, the side that I'm trying to find, let's just see what we have. I have the opposite angle. And look at this. See this side over here, the 90 kilometers? I also have the opposite angle. So what comes to my mind is more got to do with the sine rule or potentially the cos rule. Now, why can't I use the cos rule? Now, if I want to use the cos rule to find the side A, well, let's just go ahead and write down what the cos rule was. So c squared was equal to a squared plus b squared minus 2 times a times b cos of angle C. Now, if I was to go ahead and work out what this letter A equal to, well, looking at the formula, I need to have these two sides. And what those two sides are is I have this side there, but I also need to know this side over here. And that's what I don't have. So as soon as I realize that, hey, I don't have that special arrow or whatever you want to call it, the three trio, so the side, angle, and then the side, because I don't have that, I'm unable to use the cos rule. So now where does my mind go to? My only other option would be sine rule. Now let's have a look at what the sine rule said. So A over sine of the angle A would equal to B over sine of the angle B. Now look at this. I'm trying to work out what A is, right? Now, sine of A, that's just going to be the angle opposite the side. Do I have that? Yes, I do. And that's what we have over here, which was 105. So let's go ahead and write what we have so far. A, which is what I'm trying to work out, over sine of the opposite angle, which is 105. That should equal to B. Now, B is another side. Now, the only other side that I have is that 90 kilometers right there. So that's going to be like my B. Over, now, what's sine of B going to be? Just the opposite angle. And the opposite angle of side 90, that's going to be 50 degrees. So therefore, that'll be sine 50 degrees. Guess what? I just figured out how to work out my length. And now just basic algebra from here. Since A is being divided by all of sine of 105, take it to the other side, so multiply it to the other side. So we're going to get A is equal to sine 105 multiplied by 90 over sine 50. And our answer would become 113.483, so on and so on. And since the question said to 2 decimal places, we're just going to end up with 113.48 kilometers. There you go. That's our answer.